Ohm's Law. Now my joke here is meditate on this, and it's kind of a play on word. Ohm. So Ohm's formula is simply stated as this: V equals IR, where V stands for voltage in the unit volts, I stands for current in the unit amps, or represented by this A, and R stands for resistance in ohms. Now, I've seen many formulas for V equals IR. You could represent the current as voltage divided by resistance, or you could represent resistance as voltage divided by current. But I guess my point is, why worry about all the different versions of this equation? As long as you remember V equals IR, all the math works itself out. Now, there's a relationship between the three characteristics of electrical circuits. And if the voltage does not change, and I've made voltage be blue in here, if your current goes up, what has to happen to your resistance? Well, in order to ensure that V stays the same number, your resistance has to go down. And so these are an inverse relationship. On the contrary, if your current stays the same, what happens as your voltage goes up? What happens to your resistance? Your resistance has to go up as well. Hey, if your voltage goes down and the current remains the same, what happens to your resistance? It's got to go down as well, and that is a direct relationship. And then finally, just to finish things off, if resistance remains the same as voltage goes up, so does current, and that is a direct relationship as well. If we pay attention to these, can we make some generalities? Let me point out, pay specific attention to the equals sign. If the characteristics are on the same side of the equal sign, then they have an inverse relationship. So voltage stays the same, current and resistance, they have an inverse relationship. But if you are looking at characteristics across the equals sign, so for example current and its relationship to voltage, or resistance and its relationship to voltage, these are going to be direct relationships. Let's model a problem. A circuit is powered by a standard D-cell battery and has a current measured to be 124 milliamps. What is the resistance? Well, I'm given milliamps, and that is a measurement of current, which the symbol is I, and that's 124 milliamps. Unfortunately, it is in prefix notation, so I need to rewrite that, and there's many ways in which I can write it. I can write it as 124 times 10. Milli means to the negative 3 amps, or I can write it 124 e to the negative 3 amps, or I could write it in standard notation, 124 amps. Now, if we pay attention inside of our question, it kind of looks like we don't have enough information, except we say the standard D-cell battery. And if you look on the side of a standard D-cell battery, it is 1.5 volts. Ladies, gentlemen, if it is not specified the exact voltage and it says a battery, you can assume that the voltage is 1.5 volts. What if it were two batteries? You could add 1.5 to 1.5 and assume that it is 3 volts. And if it were 3 batteries, you could assume that it was 4.5 volts. The characteristic that we're looking for is resistance, and that's going to be in the unit ohm. And the equation that we are going to use is V equals IR. If I substitute numbers for letters, I know that voltage is 1.5. I know that current is 124 times 10 to the negative 3. But I don't know what resistance is. So in order to get resistance all by itself on the right-hand side, I can divide by 124 times 10 to the negative 3. Cancel, cancel. Whatever I do to the right, I need to do to the left. That's 10 to the negative 3. And when I put this in my calculator, I get a calculator answer of 12.0968. And if I clean that up from Mr. Fay's class, I get 12.10